Hey y'all, today we're going to be talking about multiplying polynomials. So multiplying polynomials and specifically multiplying binomials is something that we're going to be doing a lot in quadratics. And so we're going to explore two methods. One of them is called the box method and one of them is going to be called double distribution, because multiplying them is really just kind of like doing that distribution method that we've talked about all year long twice. But let's get into it. So when multiplying, we want to remember that we multiply the coefficients. So we don't add the coefficients, we multiply the coefficients. And just as a reminder, the coefficients are the big numbers. So coefficients are those numbers that are in front of our x's. So like 2 and 3 here, and 2x and 3x. Or when we just have a single x, our coefficient is, of course, 1. Okay, so we multiply the coefficients, but when we're multiplying x's, we add the exponents. And just as a reminder, the exponent is that little tiny number up in the top. So little numbers. Okay, and as a reminder, x is the same as x to the first, just like x is the same as 1x. Okay, so our exponents on our single x's are actually x's to the first. We just don't write the 1, just so we don't write the 1 in front when we're multiplying as well. So let's kind of explore this a little more. We're going to look at the box method first. Okay, so number 1, box method, we have x plus 5 times x minus 3. So first things first, you want to put both of your binomials, okay, they're binomials because they have two terms, on the outside of your box. So x in positive 5 and x in negative 3. Okay, now with the box method, you just multiply across the box. So x and x, see how they line up and would meet here in this box? So I do x times x, which I multiply the coefficients, which in front of both of these x's is a 1. So 1 times 1 is 1. So this would be 1. And then x to the first, and x to the first, I add 1 and 1 to get x squared. Well, that's not the greatest squared in the world, so we're going to try again. So we multiply that coefficient of 1, but we add those exponents of 1. Then x and 5, so I multiply 1 and 5, so 1 times 5 is 5. But then notice I don't have an x here with 5 to add to the exponent of my x to the first, so I just stay with x. Then negative 3 times 1x, same thing. 1 times negative 3 is negative 3. And then I don't have another x, so just x to the first. And then last but not least, negative 3 and 5, which is negative 15. And there's no x's on either of them, so we just leave it like that. Okay, so that is the box method. I've multiplied everything I need to multiply. Now, the second thing we need to do is we have to simplify our answer by combining any like terms that we have. When combining, we want to remember to add or subtract the coefficients. And then we want to remember to do nothing. To the exponents when combining like terms. Because remember, the exponents tells us how many x's we have. And so that's what makes our terms like terms. So we don't want to change that. Okay, so let's look at our box. So we have 1x squared. Do we have anything else in any of our other three boxes that is like x squared? No. So we're just going to keep it as x squared here in the front of my answer. Then I have 5x, which 5x and negative 3x are like terms. So 5x minus 3x would be equal to positive 2x. Okay, so I didn't do anything to my exponents on my x's. It stayed x. I just added or subtracted my numbers, which 5 minus 3 gave me positive 2. And then negative 15, I don't have anything else like negative 15. So it just stays negative 15. And that's our answer. That is box method. Okay, let's look at double distribution, which is very similar, but just a little bit different. So we have x minus 4 times x plus 9. So I'm going to write them a little bigger here. So double distribution is where, just like we would distribute a number, so just like if negative 4 was by itself outside, I would multiply negative 4 times x and negative 4 times 9. We're going to repeat that process. We're just going to do it for both. So I'm going to multiply both pieces of the second set of parentheses by negative 4, and I'm going to multiply both sets by x. Okay, so negative 4 times, and yellow is not the best color to choose there. So negative 4 times x, okay, negative 4 times x is negative 4x. And negative 4 times 9 is negative 36. Then x times x. So x times x, we did this before, is x squared. And then last but not least, x times 9, which would be 9x. Okay, so notice negative 4 multiplied by both in the second parentheses and x multiplied by both in the second parentheses. So you end up with the same amount of terms when you're multiplying two binomials as you do with the Mox method. Because really it's kind of like the same, we're doing the same thing, just two different ways to help organize our math. Okay. Now, just like before, we do have to look for any like terms. So negative 4x, what's like negative 4x? Well, positive 9x. Okay, so negative 4x and positive 9x, that would be 9 minus 4, which would be positive 5. So positive 5x in our final answer. Negative 36, is there anything like negative 36? There is not. So negative 36 hangs out at the end. And then last but not least, positive x squared, which there's nothing like positive x squared, so we just leave it as positive x squared in the front. Okay, so that's two different methods, y'all. I'm going to use mostly the box method because I think it helps everyone kind of organize their thoughts a little bit better, but you can use double distribution if you prefer it. You will also see it sometimes referred to as FOIL. And definitely as we move forward, you will see this called FOIL up in like Algebra 2, or if you moved up to pre-AP math, which just stands for first because we multiply by the first number in the parentheses, outside because we multiply the outside numbers in the parentheses, inside because we multiply the inside numbers, negative 4 and x, and last because we multiply the last numbers, negative 4 and 9. So FOIL is just a nice way to help you remember to do those, all of those different multiplications when you're doing double distribution. Okay. But let's look at number 3 and number 4. So number 3, we have 2x minus 5 and 3x plus 4. So 2x and minus 5 on the outside, and 3x and 4. So 3x times 2x, multiply the coefficients, so 6. X times x, add the power, 1 plus 1 is 2. So 6x squared. Negative 5 times 3x, negative 5 times 3 is negative 15, and then no x's to multiply, so just x. 2x times 4, 2 times 4 is 8, and then no x's to multiply, so just x. And then 4 times negative 5, negative 20. Same thing we did before, we look for like terms, nothing like 6x squared, so we get 6x squared. 8x and negative 15x, those are the same, so 8 minus 15 is negative 7. And of course, y'all, if you need to, you can always type that into Desmos to make sure that you get that adding and subtracting your like terms correct. And then nothing like negative 20, so minus 20 there at the end. Okay, so that one was a little harder because we had coefficients in front of both of our x terms, but still nothing that we couldn't handle. Okay, let's look at number 4. So we have x minus 7, and we have 8x minus 9. So 8 times 1, because remember we don't write the 1 sometimes. Okay, 8 times 1 is just 8, and then x times x, add the powers, so x squared. 8x times negative 7, negative 56, and then no x to multiply by, so x just stays there. X times negative 9 times 1 is negative 9. No x's to multiply, so x stays there. And then negative 9 times negative 7, which that one's getting kind of big, so if you need to, y'all, you can always check that in your calculator. But that would be positive 63. So then same thing as always, we want to look for like terms, so we have 8x squared. Negative 9x and negative 56x are like. So negative 56 plus negative 9 gives us negative 65. And then, of course, positive 63 at the end, nothing like that, so plus 63. All right, y'all, hopefully you're starting to get the hang of this. Let's throw in one extra little type. So sometimes we'll multiply a polynomial by just a mononomial, okay? Which remember, a mononomial is just a single term, binomial is for two terms, and a polynomial is for multiple terms. So anything more than two would be a polynomial, but you can also call a binomial a polynomial. It just means many terms. Okay, so let's look at number one. We have 4x times negative x cubed, negative 2x, and negative 4. So same thing as we did before. We're going to do our double distribution method, but really it's just a single distribution because we only have 4x to multiply in. So just like we did, we want to multiply the coefficients. We want to add the exponents. And we want to combine like terms. So really, it's all the same steps. We're just distributing that single term outside, and that term is going to have an x instead of just being like a number. Okay, so let's start with 4x times negative x cubed. So 4 times negative 1 would be negative 4. X times x cubed would be x to the 4th, because remember, we add the 1 and the 3, which gives us the 4. Then 4x times negative 2x. 4 times negative 2 is negative 8. X times x, add the powers, gives us x squared. Then 4x times negative 4. 4 times negative 4 would be negative 16. And then x times no x to multiply with, so we just get x there at the end. And as our final answer, we always want to look for any like terms. So negative 4x to the 4th, nothing like that. Negative 8x squared, nothing like that. And negative 16x, nothing else like that. So we would just write that as our final answer. Negative 4x to the 4th minus 8x squared minus 16x. And that's it. Okay, let's look at number 2, but we're going to use the box method this time instead of our distribution method. So we'll write 3x outside and then each of our terms up on the top and minus 1. And then we're just going to multiply down through our box. So 3x times negative 2x cubed is negative 6. X times x cubed is x to the 4th. 3 times negative 1 is negative 3. X times x is x squared. And then 3 times negative 1 is once again negative 3. X times nothing is just x, because I got no x's to multiply with. And then once again, x to the 4th, x squared, and x are all the only iterations of those type of terms. So we have nothing to combine, so we just write that as our final answer. Negative 6x to the 4th minus 3x squared minus 3x. All right, y'all, and that is multiplying polynomials, using the double distribution method or using the box method. You can use either. I don't care which one you use moving forward. Just make sure that you do use one of them to kind of help organize your multiplication, okay?